I prove the following using composite translation. So there's two translations for this. Okay, the first one, to prove it, we have to use our model of CER. Okay, so the claim can just be a repeat of this. So I can just write this as my claim that this triangle is congruent to this triangle. Perfect. The evidence would be the translation itself. Okay, so let's say we started with the point x comma y. And the point x comma y will undergo a series of transformations. So I'm going to grab this. I'm going to move it all the way here. And it looks like this. And that's a horrible shape. Like that. That looks like it went 1, 2, 3, 4, 5. Right 5. Okay. So this will arrow x plus 5. Nothing happens to the y. Then it looks like it reflect over the x-axis, okay? X-axis, all right? Okay, so here we need to just write the rule for the reflection. So then the point, let me write this point. The point x comma 5 comma y will undergo a reflection over the x-axis. The reflection over the x-axis is when the y changes. So x plus 5 stays the same and we minus the y. Okay? So we can say that these are congruent because we don't need to write congruent because it could map the figures. Maybe I can write this out much better. So I can write the two figures can map on to each other using using rigid transformations. Okay, and that would be the complete explanation. The two figures can map onto each other using only rigid transformations. Okay, that would be the complete explanation, right, for what we are looking for. Okay, I'm gonna copy this because I know I'm going to be using it again. Okay, there you go. That would be the reasoning. That's the claim, that's the evidence, that's the reasoning. Okay, let's look at B. All right, so how did we map this onto each other? You could treat whichever one as the pre-image, okay? So it looks like I want to move it here, right? I think I moved it here. Yeah, right here. Boom, boom. So it looks like it went 1, 2, 3, 4, 5. So it went left 5, okay? All right, getting ahead of myself. Claim, evidence, reason, okay? Claim, I believe these two shapes are the same or congruent, so that's my claim. My evidence, so my first part of the transformation is x comma y arrow x minus 5 comma y. That is the left part. Then it looks like it was a reflection, right? Reflection over the x-axis, right? It's a reflection over the x-axis, so the y changes, right? Yep. So x comma 5, the y changes, it becomes arrow x comma 5, the y changes to a negative y. And the same explanation here. So the two figures are congruent because of only rigid transformations, okay? There you go. Right? And let's look at C. Let's see, how much did I move this over? Oh, let's start by writing claim, evidence, and reasoning. Okay, my claim would be this. These two shapes are congruent. Right? Restate what I'm looking for or trying to prove. Evidence, let's see what I transform it into. Ooh, ooh, this is a very interesting thing, because if I reflect it, ooh, maybe there's two reflections. So look, I think I can reflect it here, like this, right? Okay. Here, I think it's better if I draw the shape. So I think if I reflect it here, yeah. Here. I'm making this shape here. So let's see if I reflect it. So if I reflect it over the y-axis first, then I reflect it again over the y-axis. This was so the first one was a reflection over the x-axis. Oh wow. Okay. So the first one was x comma y arrow. We reflected over the x-axis, so the y changes, so it becomes negative y. Then the point x comma negative y arrow, when reflected again, that becomes negative x comma, the negative y stays the same. And then we can say that the two figures can map onto each other because we only use rigid transformations. We did two reflections. Did you know you can actually do something else here for the evidence? These two reflections are actually the same if you actually do I think it's called a reflection over the origin, right? Origin. Okay. Right. This is when you change the no, wait, x comma y. Oh, no, screw a reflection. I'm gonna say it's a rotation. Haha. Why don't we just do that? It's a rotation. Rotation of 180 degrees, because look, it changes sign. X comma y arrow negative x comma negative y. You could have also just used that. A single rotation of 180 would map these two right on top of each other. Okay, so there you go. That's how you prove using transformations, composite transformations.